Alright, in this video we're going to look at vectors and how we can represent various sine waves signals as a vector, and then how we can then combine them as though if they were being combined in some sort of mixing unit, summing amplifier, that sort of thing. So certainly this has applications within audio mixing. You've got somebody on voice, somebody on drums, and all the signals get mixed together. We're going to keep it nice and simple. We're going to keep it with the same frequency. We're just going to focus in on the amplitude and the phase angle. One other thing is I'll just stick with degrees. If there's time at the end, I might do in radians, but I'll stick with degrees at the moment. Okay, so I've got two signals. I'm not worried about the frequency element, but it has an amplitude of 10 volts. And I've got signal 2, amplitude of 3 volts. It's been phase shifted by 20 degrees. So the first thing we need to do is convert these into rectangular coordinates, into x and y coordinates, because these are what we're calling polar. But I'll draw it out so you can see. So the polar coordinates, I'll draw them out first. Okay, so therefore I've just drawn out the two signals, not to scale, but that's certainly one way that we can solve this, by drawing them out to scale. To then work out the resultant. So I'll just draw a little picture of what that might look like if we were to draw it out to scale, because then you get the idea of where we're going with all of these calculations. So we can combine the two vectors. It doesn't matter where we start from. So if we go along the bottom first, or if we then take the one that's offered a phase angle, but what we can then, whichever one we do, then we can go along again, or we can go up, and it's the resultant that we're interested in. So that's the resultant that we're interested in finding, this length of this, the resultant, and then this angle, and that's what we're going to do mathematically. But certainly drawing it out, it's not the most accurate method, but it certainly does get results. Okay, so what we're going to do is we're going to convert both signals to x and y coordinates. So where does this signal 1? So signal 1, we go along 10, but we're not going up by any. So the y coordinate is 0. Okay, that's signal 1. Now signal 2, we need to do a little bit of work on it, just so we can work out what the x and the y is. So there we have a little picture. So what we're looking to do is find out what x and y is. So we need to use a little bit of trigonometry. So x adjacent, so I'm going to use the cos. Okay, so there, and then on for the y, I'm going to use the sine rule. So let's just work out those answers. Okay, so there I've worked out my x and y there by just putting them in, and I'm just going to put them in exactly the same form as I've got in the other one. So in the brackets, 2.59 comma 1.5. There's my x and y coordinates. Now that they're in x and y coordinates, it makes it nice and easy to add our rectangular coordinates together. Okay, so quite simply I've just added my x's together, and I've added my y's together. Nice and straightforward. Okay, so now I've got my x and y coordinates of my resultant vector. So the next thing we want to do is turn the x and y coordinates of my resultant vector back into what we call polar form. Okay, so I've just drawn a little picture of what information we've got and what we're looking to find out, so it relates back to the original. Okay, so we need to do a little bit of Pythagoras to work out that resultant. Okay, so we've worked it out there. So then the resultant is 15.66. Okay, so we just need to work out the angle. So I'm going to use you can use tan there for that. So let me write that. Gives me 6.79 degrees. So there we've worked it out. Again, just so we can just draw it as a picture. What does that look like? So therefore we've got something that's like that. That's what did you say? 15.66, and then the angle there is 6.79 degrees. That's our resultant voltage that we're, because I've effectively remember that's where we started off from by trying to combine two waveforms. So we're going to have an amplitude of 15.66 and a phase angle then of 6.79 degrees. Okay.